Standard 12 Chemistry, Unit 11, Alcohols, Phenols, Ethers, Part 18, Reaction with halogen acid. Here is tertiary butyl, and it is methyl, so its name will be tertiary butyl methyl ether. Oxygen has two lone pair of electron and partial negative charge, which is on react with hydrogen iodic acid. This will be positive and will be negative. This positive will attack on oxygen, and carbon bond between carbon and oxygen will break. It forms methanol, and rest of the part is negative part will attach with the butyl linkage, and it gives CH3 CH3. It is called 1 2 3 2 iodo 2 methyl propane. And the very most important reaction, this Methoxy Benzene or it is called anisole. Here this oxygen atom has two lone pair of electron, and this oxygen is directly bonded to sp2 hybridized carbon atom, which is strongly bonded with carbon atom, while this carbon is sp3 hybridized carbon atom, which is bonded with oxygen. So this makes very strong bond between oxygen and sp2 hybridized carbon atom, while this bond is less strong. So which is react with Hi. This bond will close or break, and it forms this positively charged and negative charge, so it forms phenol, and rest of the part CH3I, it is methyl iodide. And second thing, very most important, that if it react with hydroiodic acid, this form iodobenzene is not possible. It's not possible. Okay, and methanol, because this bond will never break because of the strong bond between oxygen and carbon atom, so this bond will never break. Here the bond will break between oxygen and sp3 hybridized carbon atom, and it forms phenol. Okay, so this reaction iodobenzene is not possible. Here it is biphenyl ether, which will react with hydrogen iodic acid Hi. This oxygen will attach with sp2 hybridized carbon atom on both sides, which is very strong. sp2 hybridized carbon atom. This bond is very strong bond. So cleavage of bond either on right hand side or left hand side, but in case of this required higher temperature to break the bond between oxygen and sp2 hybridized carbon atom. So higher temperature is required. On cleavage of this oxygen and sp2 hybridized carbon atom, so it forms, and this has partial positive and negative charge. It forms here, it will be negative. This will attach with hydrogen, it forms phenol, and rest of the part will attach with iodine, and it forms iodobenzene. Okay, this reaction is very most important. Let's see another reaction for ethanol. Ethanol on react with Hi. This has partial positive charge. So at higher temperature, this form bond between carbon and oxygen will cleavage or break, and it forms positive charge. So it forms ethyl iodide, and rest of the part is convert to water molecule. Ethyl iodide is formed. Now let's see about the electrophilic substitution reaction of ether. Here oxygen atom of the methoxide has two lone pair of electron and partial negative charge. In this methoxide is ortho-para director, and at ortho position is electron rich, and at para position is also electron rich. Centers, electron rich centers, and they have more electron density. Para position, and this will be ortho position. So methoxide group or alkoxide group is direct to the ortho and para position, and the methoxy group that activates the aromatic ring towards the electrophilic substitution. Methoxide will activates the aromatic ring towards electrophilic substitution. Now let's see about the substitution reaction, which is bromination. Here this anisole or methoxy benzene, undergoes bromination, bromine ethanoic acid or acetic acid. This acetic acid is less protic solvent. It forms bromonium ion, and this methoxy group is ortho para director. So bromine will attach on ortho position, and another either is methoxy and bromo position, or you can write here bromine or CH3. Okay, either you can write this structure or this structure. It is ortho bromo anisole, and it is para bromo anisole, and of phenitol. This phenitol and bromination and bromine acetic acid. C2H5 bromine, and so it is called orthobromophenitol, and it is called parabromophenitol. If bromine react with water molecule, it forms HBr and HOBr. HOBr is hypobromous acid, and chlorine will react with water molecule, it forms hydrochloric acid and HOCl, hypochlorous. And the next reaction, it is nitration. Anisole and react or treated with concentrated nitric acid and concentrated sulfuric acid. Nitronium ion is formed here. See, is the reaction between nitric acid and H2SO4, hydrogen sulfate, HSO4 minus, and from this nitronium ion is formed, which is positively charged in water molecule. So methoxide is orthopara director. So nitro will attach on ortho position, and second product will be para, and para will be always in major, this will be minor, this anisole. So it is called orthonitro anisole, and it is called paranitro anisole. Phenitol, nitration in presence of concentrated nitric acid and concentrated sulfuric acid, nitronium ion is formed. C2H5 is also ortho para director. So nitro will attach on ortho position, and it is called orthonitrophenitol, and it is called paranitrophenitol. Now the third reaction, that is Fridel-craft alkylation. Reaction or methylation. anisole, on react with or treated with methyl chloride in presence of anhydrous aluminum trichloride AlCl3, methyl chloride react with aluminum trichloride. Aluminum trichloride is Lewis acid, so it is from AlCl4 minus and Ca3 plus, which is attacking reagent. This will be positive and this will be negative, which is attack on ortho position, which is negative charge and positive charge. This will be touch on para position, so it is form methyl anisole or para methyl anisole. This para methyl anisole and it is orthomethyl anisole. And here if we used phenol OC2H5 is OC2H5 here OC2H5, it is called paramethyl phenol and orthomethyl phenol, same reaction for phenol, so anisole and phenol. Here if we used OC2H5 is phenol, okay, the same reaction. Now the another reaction, that is Fridel-craft Acylation. Mainly acylation is carried out with acetyl chloride and acetic anhydride Ca3 C double bond O CO Ca3, acetic anhydride, or it is written as Ca3CO twice O. So OCH3, it is called anisole, or it is written as either instead of methyl ethyl, it is phenol, which will react with acetyl chloride. This will be positively charged and this will be negative charge, which is on react with anhydrous AlCl3. This will be attack on ortho and para position. It forms COCH3. Now priority is for first, is second, third, fourth, fifth and sixth. COCH3. As per priority first, it is called 2-methoxy. The rest of the part is acetophenone. It is called acetophenone, 2-methoxy acetophenone, or here 1, 2, 3 and 4 and fourth position methoxy group. So it is called 4-methoxy acetophenone. Okay, so either we used C2H5 instead of methyl. It is called 4-ethoxy. Either you can write here or 4-ethoxy acetophenone. Okay, so either you can write this or is for phenitol. Okay, C2H5, and for anisole methyl group. So and the last reaction, sorry, here this anisole or methoxy benzene, which is on react with acetic anhydride. It is written as slightly different, is acetic anhydride react with anhydrous LCl3 . This part will reattach. It forms acetic acid CH3 COOH, and rest of the part COCH3 will attach on ortho position. It is called 2-methoxy acetophenone, and another product, it is COCH3 is 4-methoxy acetophenone. Okay friends, so this is the last reaction of this chapter. Next time we will discuss another chapter. Thank you very much.